of 16, when do you see square root of 16, you should be saying square, whose area is 16. That means whose side length is 4.
What times what gonna give you 16? What times what gonna give you 16? So you're gonna write it.
Hello, Professor.
Today our topic is square root. Alright, to understand the square root, let's start with a simple example. So let's say 4 square is equal to 4 times 4. You memorize that two identical number, both of them are integers, gonna give us 16. Now you ask a very simple question but important. Everything is started with question, and that is what times what
gonna give you 16? What times what gonna give you 16? So you're gonna write it.
Hello, Professor.
Now you don't want to write what times what because this is math. So you want to invent a symbol. Instead of what times what, you call it a square root. Math is all about the symbol. So instead of what times what, you call it a square root. And sometime you write it like that. And nobody gonna put you in jail if you put 2 over here. But the convention is you don't write 2 because this is the most popular way of writing a square root without writing 2. Now, you may ask, okay, that's good, but what can it do? Well, what it can do is it can undo. What it can undo, I'll put the 16 over here and you'll see what it can undo. You can get the 4. And why the 4 is important? Because 4 was the base initially. You see 4 and this is the base. You may ask a question, is the square root inverse operation of exponent? If you ask that question, you are right. Yes, root is the inverse operation for, as negative is the inverse operation for positive. Because what negative can do, it can give you the identity back, which is 0. And the division is inverse operation for multiplication because the division can do, it can spit out the identity property for multiplication and division, as the negative can spit out the identity property for negative and positive. So square root is the inverse operation for the exponent.
The exponent.
Excuse me.
Yeah.
Does the square root have any relation with the square?
When we write the square root of 16, what does it mean? It means find the side length of a square whose area is
16.
16.
16.
That means is you have a square whose area is 16 and then find the side length. So the square root of 16, when do you see square root of 16, you should be saying square whose area is 16. That means whose side length is 4. It means find the side length of a square whose area is 16. So what is the side length?
4.
4.
But
get it?
I kind of get it, but what if instead of 16 it was 20? What if it's not a perfect?
20. Okay.
Instead of 16, what if it wasn't a perfect square? What if it was 20?
Okay, so the student asked a nice question. This is a perfect square is because 4 times 4 is 16. Both of them are integers and both of them are identical number. The student asks, what if there is a square whose area is 20, then side length won't be, the side length will be identical, but it won't be integer. That's what the student asked. So then we put the square root of 20 and we're going to ask the same question. Square root of 20 means find the side length of a square whose area is 20. Now
I can find it if you want.
Yeah.
Okay.
Square root of 20.
So it's probably 4.5, I guess.
4.47.
But Professor, if you will take root 16, won't you get plus 4 and minus 4?
Okay, a student asked an important question. The square root of 16 should give us positive 4 and negative 4. Well, in the previous example, I said the square root of 16 only give positive 4. I did not say square root of 16 give us negative 4. Well, let me correct myself. The square root of 16 can give you positive 4 and negative 4. Why is that? It's because 4 times 4 is 16 and negative 4 times negative 4 is also 16. Both way you can get a positive area. So both are correct.
So the positive 4 would be in the first quadrant, negative 4 would be in second quadrant.
No, the positive 4 would be first quadrant and to the third quadrant, and both time you get 16 and both of them positive.
What if the radicand to the number inside the square root is negative?
Negative 16 instead of positive 16. Well, that doesn't exist. That doesn't exist is because, as you saw, that positive 16 can give you 4 times 4 or negative 4 times negative 4, right?
Yeah.
However, negative 16 gonna give you either 4 times negative 4 or negative 4 times 4. So they are not identical. Are they identical? They have to be identical. In this case, they are identical, right?
Yeah.
They are identical. They are not identical. That's the first problem. The second problem, you get the area negative. So you cannot get the area negative. Does that make sense?
Yeah. The positive 4 would be in the first quadrant, negative 4 would be in second quadrant.
No. It should be on the second quadrant and fourth quadrant. Let me show you.
Oh, okay. Let's see.
All right. So this one is going to be in the fourth quadrant. So square root of negative is the problem. It's problem because this one is in the fourth quadrant and this one is in the second quadrant.
Showing it.
But the cubic root, I wrote of that. If the square root is connected to the square, is the cubic root connected to the square?
The good question. The student asked if the square root connected with a square whose side length is 4, then all right, and there will be a geometry look like I don't know whether I can draw the cube. Whose side length is 4, 4, 4.
What about the cubic root? I wrote of that. If the square root is connected to the square, is the cubic root connected to the square? But if there's a cubic root, is there a hypercubic root, like a 4-dimensional root? Like,
What about less than a square root? Can you have less than?
Okay.
that's not
The question student asking is this. The question student asks this. You understand the square root. They understand the square. They understand the cube. Now they want to see whether there is anything beyond that. And that is 1th or even 0th root. How this would look like. We already know how it look like.
Square.
A square. And this one look like
Cube.
This one I'll not even try to draw. This one I'll try. This one a line whose side length is 4 and this one is a point. And this one is a square whose side length is 4 and this one is a cube whose side length is 4.
Wow.
And this one I'll try to show you.
Fall in love with math and science, especially programming.